Okay, some applications of both chain rule and reverse chain rule and other things. So what we've got to do is show that y equals x plus cos x is never decreasing. So the first thing we have to do is we have to differentiate. So differentiate x, we get 1, differentiate cos, we get negative sine. So we know that sine x runs between negative 1 and 1, which means negative sine x also runs between negative 1 and 1 because it's the same graph upside down. So when we add 1 to it, so negative sine x plus 1, that must run between 0 and 2. Now that is the differential. So the differential runs between 0 and 2, which means the gradient is never negative, so it's never decreasing. So secondly, this one with an integral one, express sine squared x in terms of cos 2x, and hence evaluate the integral between 0 and 2 pi of sine squared x dx. We can't do that one as a reverse chain because realistically it would be sine x squared. So we do sine x cubed divided by 3 cos, yeah, we can't do that because cos x can be 0. So we have to change it into one we can integrate. And you'll find that with lots of integrals, you have to change them into something else before you can integrate. So we know that cos 2x is 1 minus 2 sine squared x. So swapping these two over, we get 2 sine squared x equals 1 minus cos 2x. And then we divide by the 2 in front. Sine squared x is a half minus a half cos 2x. So we replace the sine 2x with a half plus a half cos 2x, and we integrate. So a half becomes a half x. Here, a half cos 2x becomes a half sine 2x, but don't forget to divide by the number in front of the x, which is 2. So it's minus a quarter sine 2x. Between 0 and pi over 2. So it's a half of pi over 2 minus a quarter of sine of 2 lots of pi over 2 minus a half of 0 minus a quarter of sine of 0. So that's a pi over 4 minus a quarter of sine pi minus 0, that's second bracket 0. Sine pi or sine 180 is 0, so your answer is just a quarter.